Hi everyone, in this video I'm going to continue working with making sure you understand what happens when you compose trig functions and inverse trig functions. So I've got kind of a warm-up here. This is a calculator problem, but underlying it will be that sort of understanding. So our warm-up is find inverse tangent, oh I've got old stuff in there, inverse tangent of 3. And we've got 1.25-ish. Okay, so inverse tangent of 3 is approximately 1.25, and we're supposed to explain what this means. So remember, inverse tangent, input slope. So I'm saying if I have a slope of 3, my arc length is 1.25. So this is y equals 3x. And the arc length that would land me right on this point is about 1.25 radians. Okay, so on to the one that I'm really interested in here. What if I do tangent of arc sine of 1/2? So we'll just plug in tangent of arc sine of 1/2. And I get 5.77. I'm sorry, not 0.577. So let's just go, it's approximately 0.58. Okay, and then I want to think about what this one means. And this one's a little trickier than the last one. So this time I've said arc sine. So this is my y value. If my y value is 1/2, funny I gave us this one too, because this one's actually nice. We could do this by hand, but we did it with the calculator, so let's see if we can figure it out. So pretend that we couldn't do this by hand. So I would say, okay, if my y value is 1/2, arc sine is going to pick this point, and then tangent is going to take the arc length that I give it and give me back a slope. So basically what this is saying is if you're on the unit circle with an arc length somewhere between -π/2 and π/2, and your y coordinate is 1/2, your slope will be roughly 0.58. Okay, and then let's see, change gears a little. Okay, so number 6. This is actually really similar to the number 4 stuff, but it's a little more general. I'm not giving you numerical values. I'm giving you variables to plug in. Excuse my yawn. Okay, so we're supposed to state the domain and range of these and write them without trig functions. I think I'd actually like to write without trig functions first, and then we can talk a little bit about domain and range, because that's just getting back to, do you remember the restrictions on what you plug in and what you get out? Okay, so the tangent of the inverse cosine of w. So we want to be thinking, if I'm plugging this w into inverse cosine, then I'm thinking about it as an x value. And what inverse cosine would do is give me back an arc length. Once I've got that arc length, I'm going to plug it into tangent, but just because I said it was an arc length when I got it out of inverse cosine doesn't mean that tangent will think of it as an arc length. So we want to be really careful on this step. However, in this one, I'm in good shape. Tangent does think of whatever you give it as an arc length. So it's going to take this exact same arc length, meaning we're still at the exact same point, and it's going to try and give me back my slope. So I'm on the unit circle. And I don't know very much about my location. All I know about my location is that I'm somewhere on the top half of the circle because inverse cosine forces that. So it doesn't matter where. You can picture your W wherever you want. So let's say I'm picturing that my W is this X value right here. So this little distance right here. So I have a W and I don't know what my Y is. In order to get my slope, I don't have to know arc length, but I do have to know y. That's supposed to be a question mark, by the way. Hopefully I'm not confusing people, making them think it's a second power. Mystery y. So the idea here would be just to practice what we've been doing. So if I give you a variable in the statement, it's fair game to use that variable in your answer, which means I'm expecting the slope to be in terms of w. So we'll just go down to our Pythagorean theorem and say, well, whatever w is, we know if we square it and then add it to y squared, we get 1, which means y squared is 1 minus w squared, and y is plus or minus the square root of 1 minus w squared. And we've decided already that because it's an inverse cosine, we have to be on the top half. So our y value is positive. Okay, so now I know that I'm sitting either in quadrant 1 or quadrant 2 with coordinates w comma the square root of 1 minus w squared. And I'm looking for my slope, so it will be the square root of 1 minus w squared over w. Okay, so there's the algebra for writing it without any trig functions, trig or inverse trig functions. The other question was, excuse me, what is your domain and range? So domain is asking about what the values of w could be. So there's a couple of places I can look. One is just in this first step. If I'm going to take the inverse cosine of w and I'm thinking of w as my x, w definitely has to be between -1 and 1. The other thing I can look at is when I get all done, do I need to leave any of those values out because they don't make sense? And I think the answer here is no. I am seeing this square root of 1 minus w squared. So if I'm not careful about my w, I could get square root of negative. But if w is -1, then I'm getting 1 minus positive 1, which is 0. If w is 1, I'm getting 1 minus 1, which is 0. And if w is anything in between, this will be positive. So actually, this already works perfectly for the square root. So w's have to be between -1 and 1 if there are x values. And then our slopes, let's think about this. Okay, so we start anywhere in quadrant 1 or 2. And we get back our slope. So if our point could be anywhere in quadrant 1 or 2, I actually think we're still getting a range of all real numbers. If I follow my point, I'm going to start with a slope of 0, and then it gets small positive, bigger, 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 infinitely positive. And then when I move over to the other side of pi over 2, it's infinitely negative, and then it's flattening back to 0. So I think we get all possible slopes if we move all the way through quadrant 1. Okay, let's look at another one. So if we've got cosine of inverse sine of 2a minus 1, then we need to be thinking of 2a minus 1 as our y. Inverse sine inputs y's. So I'm sitting on the unit circle. Inverse sine forces me to be on the right half, so I don't know anything about my y other than the fact that it equals 2a minus 1. So you can picture it wherever you want. Let's say this is where I'm imagining my point is. So I have an x value that's unknown. I have a y value that's equal to 2a minus 1. And the question here is, if your y is 2a minus 1, what is your x? So it looks like we just need that Pythagorean theorem walkthrough. X squared plus 2a minus 1 squared equals 1. You can FOIL this out or not. In general, I think I'm going to go ahead and do it because I can tell that my last is going to be a 1. So when I subtract, it'll wipe this out. So I see an x squared plus 4a squared minus 4a plus 1 equals 1. And the 1's drop out, so I'm just left with x squared equals 4a minus 4a squared. You don't have to rearrange the order. You could leave it negative 4a squared plus 4a. I just think this looks a little prettier. So x is going to be plus or minus the square root of 4a minus 4a squared. This is kind of a nice example of one of the times we might want to extract. So again, I won't dock you for it, but notice you could factor out a 4, and while roots can't split over subtraction, they can split over multiplication. So we could take the square root of 4 and get a 2 out in front. We'd be left with the a minus a squared underneath. Okay, positive or negative x, because we're working with inverse sine, we've already decided that we have to be on the right side of the circle. So that's going to force x to be positive. So I'm going to say that my answer here is the square root of 4a minus 4a squared. And then I'm going to try and think once again about domain and range. So 2a minus 1, domain would be what values of a work. So 2a minus 1 has to be between -1 and 1. And I know that because 2a minus 1 represents my y value on the unit circle. We can solve this inequality. So we can add 1 to both sides out here, and we'll get 0 less than or equal to 2a less than or equal to 2. And then we can divide out the 2. So it looks like a has to be between 0 and 1. So that's our domain. For the range, we forced ourselves, let's see. So we get, by plugging in a's between 0 and 1, we should actually get all possible y values between -1 and 1. And then we're looking at if our y values if our point can move anywhere on this half of the circle, what x values can we get? And it looks like we can only get positive x values. So I'm going to say that my range, since I don't have it set equal to something, I'll write it with the other notation, is anything from 0 to 1. So outputs of this are x coordinates, and as soon as we force ourselves on the right hand side, we can only get x coordinates between 0 and 1. Okay, one more of these. Again, feel free to pause and try this one on your own if you're kind of getting the hang of it. So if I input square root of 3b into an inverse tangent, then I'm saying that's my slope. So I have a slope of square root of 3b. Inverse tangent should tell me the arc length that would make that true. And then sine should take that arc length and tell me my y. So again, really I don't need the arc length. What I need to do is say if my slope is root 3 over b, what is my y? So unit circle. Because I am first working within an inverse tangent, I know that I have to be somewhere over on this right side. So we actually want to ignore all of this. Okay, so we're somewhere on the right side of the circle. Slope square root of 3b, I have no idea how big that is, but it is a positive root, so it can't be negative slope. So I actually have to be somewhere in quadrant 1. So let's just imagine here's our line and here's our point. And what we know about our point is that y over x is equal to the square root of 3b, or that y is equal to root 3b times x. Okay, so this is what we know. Our point has to be on that line. We also know that x squared plus y squared is always equal to 1, so the point is on the unit circle. So if we plug in our y, we get x squared, and this actually works out really nicely. Root 3b times x squared becomes 3b times x squared. Okay, and this starts to look a little hairy, but it is really doable as long as you don't forget that you can factor out an x squared. And I have a 1 plus 3b, and then you can divide, and then you can square root both sides. Okay, so this is where I end up. I was working with inverse tangent, so I know my x has to be positive because inverse tangent forces me onto the right side of the circle. I once again went through and just did the substitution the way that showed up most easily, but that does mean I have one more step at the end. What I really wanted to know was what is my y value. So I'm going to go back to this formula and say y is equal to the square root of 3b times the x that I just found, 1 over square root of 1 plus 3b. So sine is going to equal, I'm just going to mush it into one root. You can leave it separate, but I like this. So again, roots, you can take them apart and put them together over multiplication and division. You can't do it over addition and subtraction. All right, domain and range. So in this one, I'm plugging it into inverse tangent, which means it's a slope. So square root of 3b can actually take on any value at all. There's no restrictions on that. Inverse tangent can input any slope. So that's not a problem, but we do have a little bit of a problem just with the square root itself. We need to make sure that b is not a negative number. So we'll just say b has to be greater than or equal to 0. Otherwise, we're going to have trouble. Okay, so we get that. Excuse my yawn. Okay, so we're over here on the right side. We get that arc length, and then we ask ourselves about y coordinates. So it looks like for range, so this is for domain, and for range, our y value can be anything from -1 to 1. So we don't lose any part of the y values on the circle. All right, thanks for watching.